Hey guys, I pulled this 12 volt DC Shur-flo pump out of service because it wasn't working. So first thing I want to do is to confirm that it's actually a pump problem and not a problem with my solar system down at the well. So I'm going to connect my negative to negative on my battery terminal and my positive to positive. I have a fuse in my positive link. Always a good idea just to see and confirm that in fact the pump is not working. So let's go find out why. Okay, we determined that the pump's not working, so we're going to open her up and see why not. First thing I'm going to do is remove the heatsink. And you can see this is a Shur-flo 12 volt pump, 150 psi. Lots of good things to say about this pump, even though it's not working at this particular minute. She's given me many years of good service and has outlived her life expectancy. She's been repaired a few times, as we'll see when I open her up. So I'm pretty sure that the problem is not at the front end dealing with the diaphragm and the water flow, because I'm getting no spinning from the motor. So my concentration is going to be back here with the motor. Wire here goes to the pressure switch, which I don't use in my application anyway. This pump is used to pump water from a cistern up to my house. It runs somewhere between 4 and 5 hours at a time. Probably right at the limit of about 100, 110 psi. However, my pipes would come apart long before the pressure switch would trip anyway, but in years past some parts on that failed, so I simply disconnected it. So now we're going to open this up. We do that by removing these two screws here. Remove this back plate. Okay. I use this pipe to slip in here just to keep the brushes from snapping loose so that I can see more of what's going on. You can see from in the past where this assembly has actually broken, and I've used 2-part epoxy to keep it in service. I thought that might have come apart, but fortunately it's still holding on. So I'm going to apply some pressure here and try to wiggle this part out. Okay, here we go. So this assembly is going to come out there, and we can see the brushes, and I think this is going to be my problem here. This brush looks like it's disintegrated. It's gone. This one's almost to, obviously, near its end point. So it looks like a simple repair of just changing out some brushes. You can see the heat sink in here. I'm not even sure that that's still, not the heat sink, I'm sorry, the overheat shutoff. That's what this part is here. When it reaches 120 degrees temperature, it shuts off. I'm not even sure if that's still working anymore. However, like I said, looks like it's a simple brush replacement, and we'll get her back up and running. You can see the Durapoxy, or the two-part epoxy in here. So I'm going to get this cleaned up, and then we'll replace the brushes and get her back together and see what happens. We're located in a remote location. So even though it'd be nice to be able to go buy some new brushes at the local hardware store, I don't really have that option right now. So I'm going here to my spare parts bin and seeing what I can't come up with. They don't really have brushes that are made for this pump here. So I buy something close like this, and I file it down to a size that fits in the channels here. See, this one's a little bit too big, so I just file that down. In this case, I'll have to file that one down and then use this one. This is an older one, and you can see actually the piece of plastic that used to be here is burnt and stuck to the side of the brush. So I'm going to try to remove this plastic and reuse this brush in that channel to get me by for the next week or so until I go into town. So that's what we're going to try to do. So I got it reasonably cleaned up. One thing I want to do before I go forward, this is the heat sensor. Again, not even sure if it's working, but I want to make sure that the current is passing at least through this point, so that I know that my brush is passing it through. So I'll set my meter to my continuity setting, and I can hear from that sound. Okay, at least current's passing through it, so it's still at least in a closed state. One other thing I want to mention is that, let me pull up right here. This copper piece right here, it's kind of like a brake in its caliper. As the brushes also wear down, they wear into this copper here. And I'm just going to take a little bit of sandpaper and clean that up as well, since I have it opened. It's also good to take a look at this, because in its last failure, it actually got submerged in water when one of the hoses came loose, and the sealed pump house actually filled up with water. So looks like everything's okay. As far as the bearings, don't show any signs of rust. It's a little bit dirty, but other than that. So I'm going to take some sandpaper and clean this up, just so it'll make a better contact.